Hi everyone, good morning, and wish you all a very happy new year once again. Before I start with today's session topic, which is about migrating to our document APIs, which is SQL Core API and Cosmos DB API for MongoDB, I just wanted to, set some quick context, and in case if you are new to one of these sessions, just quickly, mention that this is a Partner Tech Connect program that we have been running for the past, I think this is the third month now. And as a part of this, we are doing monthly special topic sessions and open Q&A hour for all of our partner community every month. And we are trying to help you guys, familiarize you guys with Cosmos DB concepts and how to use the platform best, as well as looking to hear feedback and inputs and any challenges from you guys around what better would you like to see in the product, or if you're facing a particular scenario and want to know more. So this is a quick set of resources, and we will put this in the chat as well. We have the Cosmos DB beta certification that went available on 11th November, in case if you want to take it up. We have our common Cosmos partner success, from which you might have received emails already. This is a DL that you can use really for anything. If you want to get in touch with us for feedback, challenges, one-on-one customer scenarios, any of that. We also have this partner escalation request form if you want to schedule a time and get in touch with us. And yeah, feel free to forward the meeting invites to your colleagues, any other partners who might be interested and who you think should be a part of this. So that was the quick, quick overview and something that I wanted to share before we started. Let me change my presentation now. All right. So welcome again. I see a few more folks have joined. Today's topic that we are going to cover is migration to Azure Cosmos DB document APIs. So we have two document APIs, which is one is our SQL Core API, and the second one is API for MongoDB. So today we are going to this is the agenda for today. We're going to start with looking at the benefits and the top reasons why customers migrate to Cosmos DB and what you should focus on. What are some of the top industry-specific use cases? These are a few common application scenarios where document style database is extremely useful. So we'll look at a few of those common use cases and patterns that we have seen over the years. We will also look at a planning checklist. So for any new platform or any platform you're migrating to, you need to familiarize yourself and keep a few things in mind before you start. So what are those top things that you need to take care of or look into when you're planning a migration to Cosmos DB? We'll look at those few points. We will talk about two types of migration today. One is heterogeneous migration, so where you migrate between different style of databases. So one example could be relational to document style database. And the second type of migration is homogeneous migration, which is migrating between same types of database. So the example here would be migrating from self-hosted MongoDB or Atlas to Cosmos DB API for MongoDB. And lastly, the overall migration approach is usually like, assess, migrate, and then optimize. So you would still need to, monitor your deployment and make sure everything is good and see what other optimization you need to do for your Cosmos DB workload. So just a quick checklist again at the end of what those things are that you need to do next once you migrate your data into Cosmos DB. So at any point of time, if there are any questions, please feel free to put it in the chat. I do see few of my colleagues are here. And okay, I see there was some noise. I think I have muted Pankaj. So yeah, so I do have few of my colleagues here on the call. We have Saranya, Saji, Manish, and Hari. So we'll try to answer these questions. I'll keep looking at the chat as well, but feel free to put the questions in the chat at any point of time. All right, to start with, what are the benefits of migrating to Cosmos DB, right? What are the top few reasons why customers look to migrate to Cosmos DB? So the first one is scalability. We have virtually limitless data and throughput scale out available in Cosmos DB. So you need to pick the right partition key, and then we'll automatically split it into map it into the right logical and physical partitions. And as data grows, you do not need to bother about the scalability part of it. A lot of relational databases or a lot of other databases do run into this issue where, beyond a point, it is difficult to handle large enterprise workloads. So here's where Cosmos DB comes into picture. You can assign resources in Cosmos DB at database or container level. So throughput is what you need to set in Cosmos DB since it's a managed PaaS service, and throughput is measured in terms of request units. These request units are basically an abstraction of CPU memory and IOPS that you need to perform operations on Cosmos DB. And essentially, these are resources which will be available for your workload. And these resources can be either shared at database or container level. So that granularity is available. So yeah, scalability is the top most reason for migrating to Cosmos DB. Second one is it's a globally distributed multi-region service. You can easily, with click of a button, enable replication across multiple regions. So we currently are available in 60 plus regions around the world. And Cosmos DB is a ring zero service. So any new data center of Azure that goes up, Cosmos DB will be available in that data center or that region. We also offer up to 99.9959s of availability for read and write operations for multi-region deployments. So that's another key value proposition of ours. So multi-region, again, applications that require global presence do work best with Cosmos DB. We also do not have, we take away that management overhead from you. So like I said, we are a PaaS service, we are a managed service. So you don't need to bother about things like provisioning, updates, patching, capacity management, any of that. So there is minimal setup and administration needed, and it abstracts away all those difficulties of managing a database as service for you. We are also a schema agnostic database. So, wouldn't say schema free because it is either a schema on write or schema on read, right? So typically in traditional relational databases, you need to decide the schema in advance. You need to plan for that. And then, you cannot just, if it's a product that has requirement of a constantly changing schema, if it's still finding a product market fit or something of that sort, then you might need to iterate and change the schema sometimes. So those things can be difficult with relational databases. So Cosmos DB, with Cosmos DB, you can use that schema on read pattern. So that's another great benefit of document style or Cosmos DB database, right? And lastly, one of the factors is license cost. Many enterprise databases, again, come with heavy license fees. And that's one more thing that contributes to the overall TCO of your workload or your environment, right? And with Cosmos DB, you can reduce that. You can provision, or you can use just the amount of resources that you need without under or over provisioning. So that's another benefit. So just wanted to start with that quick context about the benefits. And second is what are these top industry specific use cases where Cosmos DB comes into picture, and where we see a lot of migration or even greenfield scenarios, right? So you can see all the different solutions based upon industry, but I'll just quickly cover a top, pattern of application workloads and use cases that we see. So you can see catalogs and inventories are repeated among many of these industries because that's where you can put all the data in one single document or a few documents, and that you read and write together. And that's again, one use case where document style is much more relevant than relational style. So you'll see some catalog use cases in retail, even in media and communications. So yeah, that's one common use case. We also have, we are very suitable for asset management or content management.
Include this.
Okay. Sorry, if you're not talking, can you please mute yourself? Perfect. Thank you. Yeah, so we are also well suited for asset management or content management solutions. Again, common across retail, maybe even financial services, sometimes healthcare, across the domain actually. Ordering and invoicing. Again, this is where relational databases, data modeling with its third or sixth normal form can become very cumbersome to maintain, because you can have products that have different prices at different points of time, and it's easier to just, for example, if it's a customer invoice, it just goes into one single document, and it's done with that, instead of joining multiple different tables in relational store and displaying that information to customers. So that's another great use case, ordering and invoicing. We also have IoT telemetry use cases, again, in different industries. It could be healthcare, media, even retail, while if you want to track telemetry from different mobile applications and stuff like that. Manufacturing, where you collate data from different devices or different machines that you have. So that's another common use case. And any high velocity, high velocity transactions or operations, really. So once again, across the different domains and industries. All right. So, and across these industries, once again, you have, DevOps, chatbots, single sign-on portal. So you can use Cosmos DB for either of these scenarios and use cases as well. So like I said, for any platform that you're migrating to, it's good to familiarize yourself with the platform. And these are a few things that you need to keep in mind while planning your workload on Cosmos DB. So I'll start with the most important config properties, which is the properties which cannot be easily changed once you move. So I think these are a few things that you have to plan in advance, and that will be the best for your workload and environment. So first one is the partition key, right? So you need to choose the right partition key and for your workload so that it's easily scalable. I'll cover a few points around what to keep in mind for partition key. If you're using Cosmos DB API for MongoDB, then you have option for a fixed collection. So you do not need to select a partition key in that scenario because fixed collection comes with a limit of 20 GB. So if your application or your workload is going to remain within a limit of 20 GB throughout its life cycle, then you don't need to necessarily shard it or partition your collection. So you can skip that in that scenario, but in the rest of the scenarios, you have to pick the right partition key. Second one is whether you're going to use shared or dedicated throughput. So shared is where you're sharing the throughput between your collections in the database. So you have a Cosmos DB account, and within an account, you can have multiple databases, and within each database, you can have multiple collections, right? So that's the resource model of Cosmos DB. You need to either share resources between databases or between collections. So that's where that's what you need to decide. Or you can even use a combination of either of these. So you need to decide that in advance. And the third one is, are you going to use serverless or not? So serverless is where you do not need to provision a minimum throughput for your collection. It's a pay-as-you-go model. So you can either choose an account, choose to deploy an account in a serverless mode or provision throughput mode. So that's something that you need to plan in advance. So just wanted to highlight these three key points that are immutable properties, so it will be hard to change it once you have chosen it. So those are a few top things to plan your workload around. Then we have some mutable properties. These can be tweaked and optimized later, so you don't need to, these are not immutable, so slightly less priority or slightly less risky because you can change them later, but important nevertheless, because these will decide the cost and performance, may also help with the performance management of your workload. So the first one is the throughput, right? So once again, throughput is measured in Cosmos DB in terms of request units, RUs. So you need to decide and estimate the right throughput for your application and optimize it later if needed. Indexing policy is also important because, like I said, if it's a read-heavy application, then indexes will help you. The right indexing policy and the right indexes will help you a lot in keeping the cost low of your reads. But if it's a read-heavy application, then too many indexes will also contribute to the right cost and performance of your operations. So that's something that you need to keep in mind and tweak as per the requirements of your application. The top queries and filters that you're using, index those fields and those properties of your collection. Then you need to decide whether or not you need to use autoscale. So this is another great feature available for applications that have variable traffic and workload. So you can decide whether or not to use autoscale to to vary that throughput level automatically. This is handled within the platform, so you don't need to bother about changing when you see a spike in the traffic and so on. I am not going to go into too much detail about each of these, but I do have a session that I did recently at AZConf, so I will put that link in the chat as well. It does cover a lot of, the session was around optimizing cost and performance, but it does talk a lot into detail around tips and tricks that you can use during workload planning as well. You also need to familiarize yourself with the right SDK or via protocol. So if you're migrating to Cosmos DB SQL API, then we have our first party SDK. So depending upon which language you are planning to use, do familiarize yourself with the SDK. That would be one part of planning as well. And if you're migrating to Cosmos DB API for MongoDB, then familiarize yourself with the via protocol, because that is a document that lists which syntaxes and features are supported, not supported in Cosmos DB for the different API versions that we have. So that's, again, a very important part. And lastly, choosing the right migration method. I will talk about this, about the tools and options available for migration in the upcoming slides. But you need to choose the right migration method depending upon the size of your workload and whether you're planning to do an offline or online migration and so on. So, like I said, I wouldn't go into too much detail about each of these things, but wanted to just talk about the partition key, because this is one of the very important points. So choosing the right partition key, again, this is an immutable property. So you need to plan and choose it correctly for your workload. So it can be any string or numeric attribute. It should have a high cardinality, which means you should have a good spread of values among the partition key that you choose, right? The documents that you are uploading to the workload or are a part of the workload should be evenly spread across these partitions that get generated with the partition key, both in terms of the throughput as well as the storage, right? So it should look like this. So where there is almost equal distribution of the workload across the partitions in terms of the storage space as well as request units. And it shouldn't be like this, where there are a few hot partitions or hotspots and a few cold partitions that get used not as frequently as the others, right? So key to pick the right partition key is maybe list down all your queries, see which are the frequently used filters, what are you most often reading, and so on. And also you need to keep in mind that multi-item transactions span across a single logical partition. So if you are using multi-item ACID transactions in your database, then you need to keep in mind that it needs to be limited to a single partition. So those are a few key points about partition key. And another important thing a lot of people still do not know is capacity calculator. This will help you a lot with capacity planning of your application. So maybe a quick approach here would be identify all the operations, read and write that you want to perform. Then identify or estimate the cost per operation, and then come up with the overall calculation, something like this, a table of how much each of these categories of operations would cost, and then that's how you can estimate the overall RU. Of course, you might need to do POCs and tests as well, but this would be a very important tool to help you with the planning and capacity calculation, or a TCO estimation process for that matter as well. So this is how the capacity calculator looks like. It is available on this link, cosmos.azure.com/capacity calculator. Do log in, because that will open some of the features and functionality of the calculator. So do log in, and you can even upload like sample documents to help with the estimation process. and you can specify the different types of operations, even the number of regions, and if you're using multi-region writes. So you can choose all of those settings that you're planning for your workload to be as close to the right estimation as possible. Any questions so far? I see Saranya has posted a poll. Did you know about the capacity calculator? Do vote, yes or no. Cool. So if we do not have any questions, then I'll proceed to talk about heterogeneous migration. So heterogeneous migrations are basically migrations between different database technologies. So you have migration from relational DBs like SQL or Oracle DB to Exadata, Postgres, MySQL to Cosmos DB. Or it could be some other databases like key value stores like Couchbase, DynamoDB, etc. to Cosmos DB. So I already covered the top benefits of migrating to Cosmos DB, but a few common reasons here would be schema flexibility. Again, if you're coming from relational store, scalability, and license cost. So here's a quick overview of what the migration process or what are the steps that you need to go through for heterogeneous migration. So you'll start with discovering your workload. So, how many collections, what's the data size, document or row count, and so on. Assess and then prioritize which workloads to migrate first, assess any incompatibilities, any things that you need to keep in mind, and so on. Rebuild is where you may need to do some work because it's a migration between different data models or data types essentially, and then validate and cut over. So when I say rebuild, what does that include, right? So if you're migrating between different different database types, then it could be even a app modernization scenario where it's a monolithic application that's running on, let's say, Oracle, and you need to now change it to microservices from the application perspective, as well as migrate the data to Cosmos DB. So that is one additional step if it's a monolithic application. Second thing is you may need to remodel the data. So try to envision what are the changes you need to do to move your workload from relational style to document style, right? So once again, in SQL, in relational databases, we use third normal form or sixth normal form. That is often unnecessary depending upon your workload. Or that is not how you read your data, right? You need to do multiple joins. So in Cosmos DB, you will need to optimize for or in any document style database for that matter, you will need to think about what's the data that you read and write together most often, right? And then denormalize and make your document structure such that it's easiest to read and write those set of data together, right? You would also need to change your application code because essentially you are changing the SDK and changing the database style. Your code might actually become simpler because you are with relational databases, for example, you often have ORM mappers, which are harder to use. They cause impedance mismatch because of the difference in the way the data is present in the database versus the structure that you're using in your application. So those challenges will go away. Your application code might become simpler as well, but it does need a rewrite nevertheless, because you will be changing the SDK, you will be changing your data model and your application code. So understand the read and write access patterns for your application, for your workload. What are your, again, going back to what are your most common access patterns, what data are you reading and writing together. And these things will help you in deciding the data model as well as um, your workload planning on Cosmos DB. So I'll spend a little time on, once again, talking about embedding versus referencing, because you'll constantly come across this if you're moving between, especially from relational to Cosmos DB, because once again, in relational, you're recommended to, use normal forms and, not duplicate fields or data anywhere. So here's a quick reference on when to embed or reference, right? So embed if it's a one-to-one relationship between those fields, or if it's a one-to-few relationship, or if the related items are queried or updated together. And you need to reference if it is one-to-many relationship, especially if it is unbounded. Then if it's going to be an unbounded array, then you better not put it in the same document, because then the document will kind of grow uh, in size unbounded as well, and that could be a problem. Also, if it's many-to-many relationship between the properties, or if the related items are updated or queried together, right? So that's a quick reference. And another quick example of, what does it mean when you need to change the data model, right? So here's an example of an e-commerce workload, which is coming from a relational data model. So to start with, it will look something like this, right? Where you have a customer table where you have different fields, and then you have a customer address table, which is separate. And you're using the customer ID as the foreign key from your customer table. And you also have customer password, where you're again using foreign key. Then you have product category, a product tag. Again, you're using, it's fully normalized, and you're not duplicating any fields, but that is not how you may need to read or write your data in your workload, right? This might involve multiple joins. So this is a quick example. So you have like customers, products. In products, you have the categories and product tags, and you have sales orders, right? So this was your data model, let's say in relational. But if you move to Cosmos DB, it might look something like this, right? So one, you can take advantage of the schema agnostic nature of Cosmos DB. So you can put like multiple documents together in the same collection like you're doing over here. So you can use the partition key as type. You can put product tag and product category in the same collection called product metadata, and you can filter by the type and the corresponding tag or category. You can also, again, over here, we are putting customer and sales order together in the same collection called customers collection, right? So here the partition key will be customer ID, because whenever you are querying for one customer ID, you want to see the customer data as well as the sales order details together, right? So this could be one way. And you have a products collection where you're keeping details and documents of each product that you have in your workload, e-commerce workload. So there is a full detailed session, Ignite session, around how we arrived from this relational data model to this document data model. Again, this is an example, but you can go and watch this session. It's in a lot of detail, and it covers good explanation of how we arrived at this optimization level. But essentially, the point I'm trying to drive here is this is how you might need to change your data model while migrating from relational to Cosmos DB. Then I'll talk about your overall stages involved in the migration, um, uh, especially if you're coming from relational monolith to NoSQL microservice, right? So the scaling of the app will be not will be independent to scaling of the data tier, but a lot of customers who are looking to modernize their workloads often do both of these things together, right? So if you are using a monolithic application, you can kind of see that you have these different functionalities kind of coded together in one single application, and these are not scaling and kind of working independently. So as we know, in monolithic application, just the development process might also become harder. Everything, upgrading the application code to fixing bugs, everything can be really hard in a single monolithic application. So your approach would be to kind of take out these application functionalities one by one and change that into a modular app, while in parallel moving your data from your traditional relational database to Cosmos DB. So here's what will be your original monolithic application stage, and all the requests are going to that single application through a load balancer. Next, you will pick one single use case or one single functionality of that application. Again, avoid analysis paralysis over here. Start small, start with the application that's the biggest probably pain point, and try to separate that and move into a microservice and move the data into Cosmos DB, right? So you'll separate out that functionality into a microservice and a corresponding Cosmos DB collection. And what you will do to start with is you will still route the requests through your traditional app, and the app will then delegate that into Cosmos DB, into the microservice. So once again, you can do this in two stages. And by the way, this is a very common pattern while moving from monolithic to microservice. It's called a strangler pattern, right? So you can do this in two stages. First one is where you move just the reads, right? So you move your reads, delegate your reads to Cosmos DB for that single application microservice, and then you finally can move the writes as well. So this can be split into two parts, and you start rerouting one single functionality, and similarly, slowly you completely move all the requests for that microservice to Cosmos DB, and then you keep repeating this pattern until each and every of your sorry, I think I've missed one slide over here, but each and every of the microservice is basically moved into Cosmos DB. So you started with what do you have? Ordering, I think, invoices, product catalog, recommendation, customer files, inventory, shopping cart, right? So this is, let's say, your overall e-commerce app, right? And at the end of it, you will move each of these one by one using the same approach to Cosmos DB. So that's a quick overview of what the monolithic to microservice migration would look like. So what are the common tools, the data migration methods that you can use for migrating your data from relational or other document styles to Cosmos DB? One is the Azure Data Factory. In this, you can use different types of source and target connectors and move data. Works very well for different types of databases, and different types of different workload ranges as well. Second is Azure Databricks. Again, this can help you with the ETL transformation as well, in case, especially if you're moving from between different data types. So Azure Databricks, which is the PaaS service, and it uses Spark, so you can write your custom code and use that to, and this supports huge migrations of even up to TBs of data size. So you can do that effortlessly with Databricks, right? Third one is data migration tool. So we have this desktop tool called data migration tool that you can use if you're migrating from sources like SQL Server, DynamoDB. There is this documentation that we have that has a table of which is the best migration tool to use for depending upon the source and depending upon the source, target will of course be Cosmos DB. So you can refer to this. And lastly, I want to mention Stream because this is a partner ISV solution, but it works great for online migration. So it helps. Again, Stream has source and target connectors for different databases. So you can use and APIs. So you can use these connectors to perform real-time continuous data movement and processing. So this could either be to keep the data in sync until you eventually cut over and migrate to Cosmos DB, or it could be even a hybrid solution that you have maintained for long term, right? So this is another option that you have. Also wanted to mention that once again, if you want to maintain a hybrid solution or if you want to maintain the source and target data in sync until you perform the cutover of the migration to Cosmos DB, this is an approach you can take. So you have your source database, you use a Golden Gate or the Bayesian connector to read change data capture logs from your source database. So depending upon which is your source database, if it's MySQL, the Bayesian connector will subscribe to binlog. If it's Postgres, it will subscribe to the logical replication stream. So whichever one is the right log format for your source database, the connector will use that and stream the events to Apache Kafka. And then you can use, once again, Spark to do the ETL transformation of your data and finally write to a Cosmos DB database. So this is, again, a common solution for data integration or even for one-time data movement until you want to keep the source and Cosmos DB data in sync. A few other ETL alternatives here, once again, include Stream and Informatica. So you can use either of these options as well to keep the data in sync and do essentially the incremental change data capture of your from your source to Cosmos DB, right? Here are a few use cases. Successful case studies, just as an example. So one is Chipotle. This is a retail industry e-commerce ordering solution. So they moved from a relational style database to Cosmos DB for the reasons of scalability, availability, geographic distribution, TTL, managing the data lifecycle, and all those reasons. Because document style database was more suited for that particular functionality rather than relational. So there's a public case study available, and you can refer to that for Chipotle. Then we have this example from transportation industry, which is for JetBlue Airways. And this was a migration from a parallel data warehouse to Cosmos DB. Right. So again, the reasons for migration were to handle the dynamic scaling, the massive spikes in workloads, let's say holiday period or particular times of day, flight volumes, and so on. And to perform fast and efficient queries and minimize the operations by consolidating OLTP and OLAP for HTAP. So I think they have used the Synapse link for this and build a solution around that. So this is, again, there's a YouTube video available for hey Raj, okay, thank you. So yeah, there is a YouTube video available for this solution. You can refer to that. It's a great example and a use case. The next case study is from healthcare industry. This was the Oracle IBM migration. Again, the use case here was claims processing and data democratization. So the customer migrated over here. This was a huge enterprise again from the healthcare industry, and the migration was done for SLA availability, performance, reasons, and all the claims data for the company was stored in Cosmos DB. And lastly, we have this example from manufacturing industry, which was the H-based migration. Again, high rate of ingestion, high velocity operations, and this was the Iot Telemetry Use Case. Again, like I said, it works great with Cosmos DB and from the scalability and performance standpoint. So in this case, the enterprise moved their backend data environment vehicle telemetry service to Cosmos DB. Lastly, a quick overview of the homogeneous migration solutions. So these are when you migrate between same database technology, so self-hosted MongoDB or Atlas to Cosmos DB API for MongoDB. So here, the reasons for migration are, again, top reasons are scalability, availability, and reducing the management overhead. So homogeneous migration, MongoDB migration is relatively much simpler. You do not need to rebuild the entire application. So this part could be as easy as a lift and shift. But I will request you to, nevertheless do all POCs and, like I said, go through the via protocol documentation and test your features and syntaxes and so on. But essentially, Cosmos DB provides a via protocol compatibility for API up to 4.0, which is the latest API. And you can use your same old traditional MongoDB drivers. So it could be a Java, Node.js, Python, .NET, Ruby, or any other MongoDB driver that you are already using, and continue to use the same existing tools, drivers, libraries, and the same existing apps and SDKs, and just move your data to Cosmos DB. So this could be as easy as just changing the connection string of your application and pointing it to Cosmos DB, right? So again, it could be minimal or no change to the application code. So the overall migration process becomes much simpler, right? So what are the data migration methods available in this type of migration from self-hosted or Atlas MongoDB to Cosmos DB? So the first one is database migration service. This is a fully managed, ready to use service that's available in the Azure portal itself, and it supports online and offline migration. So this is great for doing that incremental sync of data before you cut over to Cosmos DB, right? So it simplifies, guides, and automates the migration for your workload. Works great for small to medium-sized workloads, and more importantly, this one is free. Even the online migration is only supported in premium tier, but it is free for the first 6 months. So it's great for reducing and keeping the cost low for your migration. You can, of course, use a native MongoDB tools as well over here for offline migration. So you can use, these are tools that customers are very often familiar with, those who come from MongoDB background. So Mongo dump, Mongo restore, which are BSON-based dumps, and Mongo export and Mongo import. These are JSON or CSV based and can be used to even migrate subset of data. So you can filter with the Mongo export command only the data that you want to export, and even choose to migrate just that. And these can be used with different types of clients like Mongo Shell, Studio 3D, RoboMongo, and so on. So again, this is free and works great for a lot of customers who who are already familiar with MongoDB, right? The only consideration here would be it's not familiar with Cosmos DB throttling concept, so you would need to handle that carefully or handle it in a custom manner. Then we have, once again, Azure Data Factory. Azure Data Factory and Azure Databricks are, again, pretty much common. You would have seen, I mentioned this in heterogeneous migration also, because, again, Data Factory is a fully managed serverless data integration service. It has connectors for different databases. So it's, again, easy to set up and use. A few considerations here. You need to create pipeline individually, and there is a lack of checkpointing and dead letter queue, and indexes cannot be migrated. So you'll have to create them manually on the target. You also have Databricks, once again, PaaS solution using Spark, suitable for anywhere up to extremely large data sets as well, going into TBs. So here's a quick flow chart on migration method to use, how to decide which one to use well. So if you're using offline, if you're planning for offline migration, then depending upon your MongoDB workload size, you can, if it's a small one, you can simply just use Mongo export and Mongo dump, minimal overhead, minimal effort, and you'll be done with the migration. If it's a medium workload, you can either use DMS or ADF, and if it's a large workload, you can use Spark, either a custom installed Spark or Azure Databricks. Again, if you want to make it simple. For online migration, you can either use a custom solution like Spark and use chain stream. Again, Debezium, Kafka, whichever one it is, you can use that as well. And you can even use Azure DMS, which is out of box available for online migration, right? Also wanted to mention another partner solution over here. We have Kinesi Solution Accelerator from Nudesic. So again, this works for homogeneous and heterogeneous migration. I see Abhilash is also on the call. He's from Team Nudesic, who worked on Kinesi. This solution is available in the Azure Marketplace, so you can use this solution accelerator as well. So, few examples of successful case studies for homogeneous migration. These are all MongoDB migrations. So one is a global financial services company, and their main challenge was the extremely high cost because of licenses and the number of operations in general. And we also reduced the administration overhead here and saved up to 80% in the annual licensing costs, right? Second one is a retail company with over 2,000 stores across the globe. These were e-commerce and store applications running MongoDB databases, and the benefits that we brought in were auto sharding and elastic scale-out model. And in this case, the customer reduced, or rather, increased the performance by 1.5 times through lower latency, right? The third one is a large ISV specializing in business applications. So in this case, they moved off a third-party hosting provider where they were essentially self-hosting and managing their MongoDB instance. And the number of databases, were limitless in Cosmos DB. So, and also, they were able to comply with the data sovereignty laws, GDPR laws, and so on. And lastly is a large healthcare company. They modernized their application to Cosmos DB to help reduce the on-premises cost. Chose Cosmos DB over MongoDB Atlas as the feature and performance matched the specific transaction patterns and scale benchmarks that they had. Once again, reduced cost over here. Lastly, as I mentioned, it's not complete just after you move your data to Cosmos DB. You will still need to monitor and optimize your solution, see if there are any tweaks needed based upon your performance and workload patterns. So a few things that you can do over here is optimize the indexing policy, make sure you're using the right consistency levels. We have 5 consistency levels available to choose from, ranging from strong to eventually consistent. So choose the best one for your application, for your workload. You can configure geo-replication. You can add, remove regions as you need. Automatic failover, again, make the best use of HADR, and you would probably have planned this in advance, but you can change this later and configure or tweak it later as per your requirements as well. You can use metrics and log analytics to monitor performance. Metrics is available out of the box. It's free. Log analytics is something that you might have to pay a little extra, and depending upon what data you want to be logged, you can tweak and configure it accordingly. We have backups. We have periodic and continuous backups available now. So you can do point in time restores of backup for up to 30 days in continuous backups. So you can choose the right backup option for your workload. And you can configure the networking and firewall, again, from security standpoint as well as general hygiene standpoint. Configure the firewall, the right private endpoint settings, and so on. Restrict the traffic flow to your database. And you can even use built-in Jupyter and C# notebooks for doing any operations and stuff like that. So yeah, so those were a few post-optimization tips and techniques. Lastly, since we are talking to all our partner community over here, do share with us if you have some migration solutions or patterns that you found extremely useful. Any success stories? We would like to publish those examples and those success cases more and more. So really happy to hear about any success stories, any patterns that you applied in the migration, or even if you have your custom solutions, just like we spoke about Stream and Udesic, if you have similar solutions or different solutions, you can share that with us. And of course, any challenges, feedback, happy to hear about those as well. That's all I had for today. We are right on time. Any questions on chat, or you can unmute yourself and even ask?
Shweta, I have one basic question. So if I have a on-premise solution relation database, maybe SQL Server, and I want to migrate, so should I migrate to a Azure SQL DB or should I migrate to a Cosmos DB? How do I decide the which option I should go for, and which will suit my use case?
Yeah, so a couple of things over here, right? You mentioned, so one is which model do you want to use, right? Do you want to use a document style data model, NoSQL style data model? Then Cosmos DB fits perfectly. If you are moving to Azure, then you are essentially doing a homogeneous migration, which is you're sticking with your workload is already relational or SQL, and you are moving to SQL workload, right? So your data model, your application code will majorly stay the same in that case. So it will be rather, a lift and shift and not a rebuild. So one would be which type of data model do you want to use? That would be the first deciding point. Second, again, in Azure SQL, I don't know if you mean a VM or a managed SQL service. Again, depending upon how much you want to, uh, how much of management and self-hosting you want to do. It could either be a VM where you just do a lift and shift of your on-prem, but you will still have to, take care of the upgrades and patching and all those things, your SQL security and so on inside the VM. Versus in Cosmos DB, it's a completely managed database. It will scale up and down as per your workload
Yeah, I'm not talking
requirements.
about VM, but I have
Mhm.
more managed SQL, Azure SQL DB, or
Right.
uh,
So one deciding factor there would definitely be what's the scale of your workload. If it's something that you need a global distribution and a limitless scale for, if it's a huge enterprise application, then again we have SQL hyperscale, but Cosmos DB is also a globally distributed limit scalable database. So that would be one deciding factor as well. And second most important would be choosing between that relational versus document style or NoSQL. So that would be another key deciding factor that will determine which one you want to migrate to.
Okay, but from
Yeah.
this is from a more of a modeling, that is from technical
Mhm.
solutioning. But from a business perspective, business will not worry about is it a document style or a relational style.
Mhm.
But from the ROI perspective, which will be a better solution?
Um, See, I mean, the reason why I mentioned data model is because that will determine your overall approach depending upon what's your requirement. But see, from ROI perspective, again, it depends upon what you're trying to achieve with your application. So uh, again, let me go back to the slide where I spoke about the few reasons, top reasons why people migrate to Cosmos DB. So these would be if your requirement is 99.59 of SLA, if your requirement is global distribution and limitless scale, then I would say use Cosmos DB. Your business ROI is kind of related to your technical requirement. Again, going back to how much effort you're willing to put if because changing your application from relational to um, non-relational will cost you money and time. So again, that is kind of tied together. So that's the reason why I'm saying. But yeah, you would need to think about these points.
Thanks, Suja.
Thanks, Amit.